All right, well, thank you all for coming, and today we have what we call the IGERT Distinguished Speaker Series. As most of you know, the IGERT program is designed to recruit PhD students specifically into our theme of smart environments. And as part of that, of course, we want to bring in distinguished speakers so we can hear about their work and they can hear about ours. So today we have Ronald Metoyer from Oregon State University, the School of Electrical Engineering and Computer Science there. And he also is starting up an IGERT program there on aging sciences. And so we're going to hear about that today.
All right. Thank you, Larry, for the introduction. I'm probably going to need a little help from you guys as we go through here, because I'm going to have to hit the advance button on both of these, and I know at some point I'm going to do it on here so I can see my notes and not on here, and so just let me know if you're seeing something different than what I'm talking about. I do it all the time with my students, so they warn me. Thanks a lot for coming to the talk. I was telling Larry earlier, this talk will probably be different than a lot of the talks you've seen in the past in your IGERT colloquium, mostly because I'm coming from an IGERT program, and what I'm going to do is hope to give you an overview of our IGERT at Oregon State University, and some of the projects that are going on in our IGERT, and spend hopefully about half the time also talking a little bit about some of the research projects that I've been working on at OSU. So again, my name is Ronald Metoyer. Like I said, I'm an associate professor at OSU. I've been there since 2001 now, so it's been quite a while. And I'm going to start by telling you a bit about our IGERT program. Let's get these buttons in the same place. There we go. Well, that didn't work as planned. Hold on a second here. Let's fix this. You're not going to see anything different, but I will. Okay, so our IGERT is titled Life in an Aging Society. The PI of the program, let's go back here, is Dr. Karen Hooker. She's a social psychologist. She's also the director of the Center for Healthy Aging Research at Oregon State University. And we just started our program this fall 2011. So we had our first cohort of students start up. We actually admitted 6 students. Now I know it says 9 students there, but we admitted 6 students who are funded by the IGERT, and our 6 new students. And then there were 3 students who are participating in the IGERT, but they're funded through other mechanisms. Like some of them have university fellowships of some sort or the other. So we have 9 students who are participating in the activities right now. The structure of our IGERT program is that it's broken up into 4 core areas. And these core areas were the 4 cores that were originally under the Center for Healthy Aging Research. There's the Diet, Genes, and Aging core. In this core, the researchers are looking at the biological mechanisms underlying aging processes, and their goal is to find strategies for maintaining and promoting good health. The next core is the musculoskeletal core. They're looking at methods to preserve functionality, to prevent disability, optimize overall well-being. They look at things like falls prevention, interventions for promoting exercise, and how to improve bone health. They actually have some really cool research there. Mike Pavel is one of the co-PIs. He does work in falls prevention. He has this really neat apparatus for slipping people, as he calls it. They put people in harnesses so they don't hurt anyone, but he can cause falls, actually, and be able to record them with motion capture equipment. So some really neat work being done there. The next core is the psychosocial core. They look at aging individuals and their families in the social context. And they're interested in things like how stress affects aging and how people cope with aging and how they self-regulate. And so one of the co-PIs, the PI for the IGERT project, Karen Hooker, this is the area that she's in, and I've done some collaboration with her, and I'll talk about that later on in the presentation. And the last core here is the Gerontechnology Core. That's the core where we look at design of supportive technologies. How do we help caretakers? How do we help people age in place? How do we enable some of the research that some of the other folks who are doing aging research need to do? So sometimes as computer scientists, some of the work we do is more enabling than it is core research. They also look at issues like privacy and the social and ethical ramifications of doing monitoring on people. So those are the 4 core areas that make up our IGERT program. And gerontechnology is where most of the computer science people would live. We actually only have one student right now who's a computer scientist. My arrow's got a little messed up here, but basically it's interdisciplinary. The cores, there's a lot of work going on between cores, and that's the goal of the program, is to train students to do this interdisciplinary research in aging and to be able to kind of cross these boundaries when necessary. So please feel free to stop me at any point if you have any questions. I forgot to say that up front. Let me catch myself up over here. There are kind of 2 themes that are overarching themes for our program. Those 2 themes are the rate of aging and what we call engineering aging. In rate of aging, we're referring to efforts aimed at understanding the kind of basic mechanisms of aging, and where rate is the different trajectories that we can take, physically, mentally, psychologically, and so on. So rate of aging is one of the themes that we're interested in. And engineering aging is the other theme that we talk about a bit. And that's just our mission to improve the quality of life by engineering environments to help aging, engineering interventions to help aging, and so on. Okay? Okay, so that's the basic outline of our IGERT program. I didn't provide a lot more details to it. If you have more interest in knowing more about our IGERT, I could talk about that a little at the end. I have another slide with some more kind of just details about how the particular program runs, the kind of thing you could grab from the website. What I'd like to do now is talk a bit about a few different projects that are being run under our IGERT. And specifically focus on this Gerontechnology Core. So these projects that I'm going to talk about are mostly from folks in the Gerontechnology Core, although they're reaching across some of these boundaries, so there's some collaboration with folks in the Psychosocial Core, maybe even one in the Diet, Genes, and Aging Core as well. And then after I present a few of those, I'm going to talk a bit about some of the work that I've been doing that also fits under this umbrella. So the first project I want to talk about is called the PE Fit project, or Person Environment Fit. This is a project being run by Carmen Stegel, who's one of the faculty members in the Gerontechnology Core, and her student, Laura Lien. And Carmen's interested, generally speaking, she's interested in looking at the built environment and aging within the built environment, okay? And trying to figure out how to use technology to help older adults age in place, how to aid them in their activities of daily life, and understanding, for example, how we can use technology to maintain this meaning of home and attachment to place, especially when someone has to leave their own home and go live in something like an assisted living facility. So that's the kind of work that Carmen's interested in. They're working together right now to answer this particular question, which is, can we identify problems in the fit between the individual and his or her environment so that appropriate environmental interventions can be made? So that's what that's what Laura's looking at for her work that she's doing under the IGERT. And oops, got to advance here. This is going to be a tricky process. Get a little water here. So in this project, this PE Fit project, their ultimate goal is to develop this measure of the physical capacities of the person and the barriers in the environment, and somehow be able to provide a score for how well they fit together. The underlying theory for this work is based on Lawton and Hemo's press competence model. Some of you may have heard of this before. It was something that was fairly new to me, but it's illustrated here in this picture, and I'm supposed to be using the mouse to point to things. In the press competence model, we, for example, represent the competence of the physical competence of the individual along this vertical axis here, so low competence to high. We represent the environmental press, or the environmental demands on the individual, on the horizontal axis here, from weak to strong. And the goal is that hopefully the person is fitting their environment such that they fall somewhere in this zone of comfort, right? So that whatever they have to do within their environment, hopefully they fall within the zone of comfort. Now, to give an example, you can imagine an older adult in Corvallis, or we could say Pullman. They're fairly similar so far in a lot of ways. Taking her drive to the grocery store. It's a beautiful day like it is today. And let's say she has some vision problems and maybe some slow reflexes, right? So she might be lower here on the competence axis, but the press is fairly weak, right? It's the trip she's taken before. It's not raining. It's a beautiful day. It's an easy drive. So she might very well be in her comfort zone, right? Whereas if she were on the highway going somewhere she hadn't gone before and it's pouring rain, well, we take that low competence that she has, because we can't change her physical competence, and we put much more demands on her from the environment, then she might be in an area where there's potential negative effects happening. Okay, and so that's the theory underlying the work that Carmen and Laura are working on. And so they want to be able to build specifically home environments so that the person-environment fit is very good, and that for most of what they have to do, they fall within this zone here. The method that they're using is they're using a tool called the Housing Enabler. It's a tool that was developed in Sweden, and it essentially provides a score. It assesses the PE fit of the homes for the older adults. It was developed in Sweden, though, and it is developed with respect to very different regulations and what's the other word? Standards and housing policies and so on. So the first thing that they're doing is they're adapting that to the U.S. For Laura's work, and then they're looking at modifications, because it does not include any measures of the emotional and cognitive aspects of connection to home. And so they're trying to fit that into this model. So that's one example of the kind of work that's going on in the Gerontechnology Core. Okay, and neither one of those people are necessarily technology folks. They're human design and environment folks, but they're looking at how do you kind of match someone's environment and the technology in their environment to their skill set. Catch up here. Okay, so this next project is one that actually does fall within computer science, and it's a brand new project, so they just started this. It's being carried out by Carlos Jensen, who's an associate professor in computer science. His specialty is human-computer interaction and also software engineering. He does a lot of work in the open source software community. And his student, Jennifer Davidson, is one of our new IGERT students. And so they're looking at this particular question here, which is, can we utilize retiring programmers to improve the diversity and productivity of open source software projects, and possibly also maintain the cognitive skills of the programmers? So it kind of has this two-way relationship. You know, if things go as perfect as they could in this project, they'd find that adding older adults to open source software projects helps the project in some way, and it also helps maintain their sharpness, their cognitive skills after retirement. So, why are they interested in retired programmers? Well, we've got a lot of retired programmers coming offline or online, depending on how you look at it, coming off of their regular jobs and into retirement. They potentially are very used to a corporate environment. They might have very good management skills, organizational skills, and these kinds of things are generally not what you see in the open source software community. The open source software community is dominated by very young, mostly male programmers. Okay, and so very, very different communities in that sense. But on the other hand, they are very similar in that both communities are often very volunteer-driven, right? A lot of people retire and they get into volunteer activities, and we know that open source software is pretty much a volunteer activity. And they often have a very strong sense of altruism. So there's some very serious differences between these two, but there are also some important overlaps. And so Jen's interested in trying to take these retired programmers and seeing if we can use them to help, first of all, diversify the open source software community. So take up open source software project, diversify it by adding some of these folks with strong programming skills, but also some other skills that these younger people might not have in terms of project management and organizational skills, and so on, maybe even social skills, and seeing if diversifying that project has any effect on the software that's being developed. And I should also say that, as you age, and you might start recognizing things like accessibility issues that you didn't recognize when you were younger, right? Your eyes start going, you might start realizing that, hey, this software, and I should also mention she's looking mostly at user interface software. So this piece of software could be better designed, right, if I paid more attention to accessibility issues, which sometimes may not be the case over here. So that's the kind of thing she's interested in. They're designing a study. This study is going to be based on a couple of parts here in what they call the open source continuum. So they've kind of built this diagram of what they call the open source continuum, where you've got the less technical people on the less technical ways of contributing to the open source project on the far left, more technical ways of contributing to the open source project on the far right. And so you could see, for example, documenters and bug submitters, that's a less technical requirement, whereas the coders and software architects, that's a much more demanding, a more technical requirement. So she's interested in looking at two of these areas. She's interested in doing a study with using older adults as designers, so to help to bring them in, do participatory design studies with older adults to right now she's looking at designing a mobile healthcare app of some sort. They haven't identified which one, but part of the process of bringing people in is going to be understanding what it is they think would be an interesting app to work on, and then they're going to go through participatory design studies in that area. And ultimately, she will also be doing some work with having some older adults contribute to a code development process as well. Okay, and she's going to use these two studies to just try to get a better understanding of how they affect the diversity of the open source project, and how having them in the project changes potentially the final results that they're going to get, or changes the dynamics of the open source project team. And like I said, this is a very new project. She's just getting started. She's like in the IRB approval process right now to start doing some of the participatory design studies with the older adults. Any questions so far? No? Okay. Let's see. Okay, so the third project I want to talk about a bit here is one being carried out by Patrick Chang. He's an assistant professor in the School of EECS. And Patrick is not mentoring any students from the IGERT program right now, but he is collaborating with a couple of different IGERT faculty. I'm going to talk about one of the projects he's working on that I think is probably most interesting to you, and some of the stuff that you folks do here. And in general, he's interested in non-invasive monitoring. So the question he's trying to answer is, how do we build low-cost, scalable, non-invasive solutions to study both aging and to both study aging and to improve independent living? So the solutions he's looking for might help another scientist carry out their work by allowing them to collect the kind of data they want. But he's also applying, some of his sensor technology to the person directly living in the home as well to help them live more independently. So one of the areas he's looking at is walking speed. And why is walking speed interesting? This graph tells us a little bit about why walking speed might be interesting. So here we've got speeds from 0 to 1.4 meters per second. I should do this over here. And down at the bottom of the chart here, we've got some ranges that show, for example, a household walker is typically in the 0 to 0.4 meters per second range. A limited community walker might be 0.4 to 0.8, and a good community walker might be here in the 0.8 to 1.4 range. Okay? So we've got these ranges that kind of distinguish your skill level in terms of walking. And if we go up here to the top, we see what speeds are typically associated, for example, with people who are dependent in their activities of daily life. So 0 to 0.6 might be people who are dependent in some ways in some of their basic activities, whereas people who are living independently in terms of their ADLs, they typically have this walking speed of 1 to 1.4 meters per second. And generally speaking, when you're in this range here, you're more likely to be hospitalized at some point, whereas over here, you're less likely to be hospitalized. And I wish I had a citation for that. I got this from Patrick. I'll have to get his source for this, for those of you who might be interested. And so what's interesting is that, you'd like to be able to monitor walking speed, first of all, to be able to determine when people make a transition from one of these ranges to the other, specifically from the independent range or the less likely to be hospitalized range over to that range there where there's potential problems. So monitoring walking speed is something that's useful and important. Unfortunately, the way that it's typically done these days is in the clinic, where they literally have a stopwatch test and they bring people in, and they start them walking, they give them some time to accelerate, and then they time them for, I think it's a 10-meter time section, and then they have the stop the clock and they have a deceleration time. So that's how they essentially monitor their walking speed, right? And so that's obviously not ideal solution. It only happens when they come to the clinic. It's in a clinical setting. Who knows if they're really walking their regular walking speed? So there are lots of possible confounds in doing it that way. But that's how it's typically done. So you'd like to be able to automatically monitor walking speed. So what's he doing? Well, he's developed this piece of hardware here. So he's an EE guy. He builds circuit boards. He builds controllers and so on. And so he built this prototype device here that you see mounted on the shoe right here. And if we look over at this blow-up of the device, we see it has a wireless transmitter on it. It's got some other stuff I don't know much about, regulators of some sort, magnetometer, which he says they're actually not using the data from that right now, but it's got a gyroscope and accelerometer. So you can get orientation, you can get acceleration, and so on. And you also notice that he's got an RFID tag here, and that's actually part of the system as well, and I'll explain how that works in a minute. But basically, the algorithms behind this piece of hardware is that the software is running a dead reckoning algorithm. For those of you familiar with dead reckoning, you essentially imagine the person starting in some position, in some orientation, some position, some orientation, and then they start walking. Well, you get their acceleration information. You can figure out how far they've traveled in a particular direction. You can get a new position, and then you can repeat that process over and over again, right? And so you can figure out where they're going. And that works great, except for any small errors in there start to build up, right? And those errors start to build up, and we'll see in the next slide what those look like. And that introduces problems. So he uses the RFID tags for resynchronizing as they move throughout the environment. So here's an example here. This is just a graph showing some tracked positions in red. Here we go. In red, we see tracked positions using the dead reckoning algorithm without the synchronization to the RFID tags. And in green, you see what you get when you have the synchronization to the RFID tag. So it improves your ability to track accurately significantly. So he did an example demonstration of this in the Kelly Engineering Center. That's where the School of EECS is housed at Oregon State University. And so this is like, I believe, is this the entire building? Yes, this is the entire building from the top to the bottom here. And this is like a major hallway, another major hallway, and then the connecting hallways. And so without using dead reckoning, if he put this on somebody's shoe, had them walk, he'd get this path traced out in the red here. So clearly that's not working. This is the atrium area, so you would literally be floating in space there. So that's not correct. If he puts just 4 of these RFID tags into the environment at these corners here, he significantly improves his tracking capabilities, right? And so it's the people are in the hallways where they were supposed to be. And so this is an example of the kinds of things that he's been working on. He's also done some collaboration with Chris Scafidi, who's another assistant professor in the computer science department. And Chris is doing some work in cloud technology. And so they took an environment here. They put a bunch of these RFID tags within the environment. They found they could put up to 7 people in that environment, and with these pieces of hardware on, they could walk around and collect data from 7 people simultaneously in real time. And they would essentially have the wireless transmitter from the device send information out through a smartphone and push that onto the cloud from there. And this chart is just showing when the latencies started. So they weren't having latencies until they got to around that 7th user in blue, and then we started seeing latencies. So that's kind of the limit that they hit there. So it's really interesting work. You can imagine it allows you to both get walking speed, right? So if we can track the person, we can figure out their walking speed. We also get position within the environment. So it's kind of doing two things at once, which is great. Let's see. Patrick also has some other projects going on with sensing that I'm not terribly familiar with, but I'm pretty sure we could get those at his website. He's doing some really, really interesting stuff with several members of the IGERT faculty members. Okay, so are there any questions about any of that stuff so far, these kinds of projects? Because I'm going to make a bit of a shift in what I'm talking about in a minute. Okay, so those projects, let's see, just to kind of summarize, we had a electrical engineering group doing hardware stuff. We've got a computer scientist doing the open source software stuff. And the other one was from human, I never remember the name of the department. I believe it is human design in the built environment or something like that. So fairly broad range of topics within just the Gerontechnology Core. Okay. All right, so next I'm going to talk about a project that I worked on, and this was done in conjunction with Karen Hooker, who's the PI of the IGERT program, her student Shannon Mejia, you've got myself, and my student Tuan Pham, who is not part of the IGERT program. And we were looking at this particular problem. So how can we effectively study the behavioral and social mechanisms driving healthy aging processes using online measurement tools? Okay, so Karen was very interested and excited about using online measurement tools instead of the tools that they typically used, which was maybe sending out surveys or calling people or going to people to collect the kind of data that she needed to collect. And so she wanted us to help her build these tools and run some studies. And we found some interesting areas of research in it for us as well, and I'll talk about those, us meaning the computer scientists on the team. So we've got social scientists and computer scientists here. So the goals, so PULSE, I should have said, stands for Personal Understanding of Life and Social Experiences. So Karen's very good at coming up with these acronyms and making the words fit well. And so the goals of this project were, one, to study the linkages between personality processes and health using what they call an intra-individual variability design. That's a hard one for me to say. I'll try and explain in a little bit what that is, or at least why it's interesting. And within that, she's looking strongly at self-regulation of goals. From my perspective, I was very interested in looking at how to engage participants through data visualizations. Okay, so how do I take the data that they're providing to us on a regular basis and feed that back to them and try and use that to engage them in this process even more and engage them potentially in behavior change. And another thing that we were looking at is exploring the temporal frame that's necessary for doing this intra-individual variability research. So generally speaking, this research required that you did regular recording of data or capture of data somehow over a fairly long amount of time, in this case 100 days. She was interested in looking at the possibility of cutting that down and doing bursts of collection, so 7-day bursts. So doing 7 days of collection and taking a few weeks off and doing another 7 days of collection and so on. So she wanted to find out, she wanted to study whether you could reliably do that and get the same kind of results that you would get in the 100-day continuous case, as we called it. So these are some of our goals in this particular project. Let's see here. Oops, wrong one. Let's go here. So I want to talk first about variability versus change and why this is important to Karen to study. And so you can imagine the way things work in a lot of measurements that are taken in this social psychology field that she's in. You would get some baseline data, and then maybe 6 months later you would go survey them again and get additional data, and then maybe at the 12-month mark you would get more data, and you'd try and use that to make some kind of conclusion. So let's say we were measuring their positive affect, their positive mood, essentially. And you took some measurements, a baseline measurement. This could be somebody's mom at an assisted living facility. You take another measurement at 6 months, and then you take a measurement at 12 months, and you get something like this. That doesn't look very good. It looks like there's some kind of decline happening, right? But let's say alternatively, you took measurements and you got this at the baseline. You got something like this at 6 months, and then you got something very similar at 12 months. You'd look at that and say, that looks pretty good, right? It looks like they're staying pretty level. The positive affect or whatever function it is you're measuring is staying pretty consistent. But when you look at the actual data, if you were able to take data at a very regular, a much higher rate, you might, for example, get a picture that looks like this, which says generally that at that top example there, there was not much change, right? A lot of variability, intra-individual, so this is a single person, and a lot of daily variability, but not a lot of change overall, right? None, basically. Whereas at this one at the bottom, the data may have looked like this, and just because you happen to sample at certain days, you wouldn't have caught this change, right? So there's clear change happening here over time, clear decline happening, but overall you would not have caught that. Okay, so this is why she's very interested in doing this high-frequency collection of data and looking at this what we call intra-individual variability, this variability, as well as long-term change and the relationship between the two. Okay, that's her area of research. So she wanted to study that. She wanted us to help her build a system. She was also very interested in dynamic process coupling. Basically here, advance here. My notes. So basically here, she wants to look at the coupling between, let's say in this case, cognition and stress. So we've got stress going up and down for this particular person. At the top image here, we've got what she would call cognitive resilience, meaning even though that person's stress levels are going up and down, their cognition isn't being affected in a big way. All right, it's being affected, obviously, but it's not going up and down as much as the stress, and it's not going up and down in the exact same cycle. Whereas you might see something like this for someone that has cognitive context dependency, where their stress goes up and their cognitive skills go down. Okay, I know the curve goes up, but the skills go down in that case. And so this actually is something that's very important to look at. This happens to be, according to Karen, an indicator of what she calls mild cognitive impairment, which is a precursor to Alzheimer's. Okay, so she wants to be able to recognize and find things like this, but it requires that you capture information on a regular basis. And sometimes it's things that you can't necessarily monitor automatically. It has to be potentially self-report data. Okay, and so let's go to this one here. She designed a study. The way she wanted the study to work was that there would be an initial survey. In that initial survey, the person's goals would be populated. So she's going to look at intra-individual variability. So she's going to collect a lot of data, look at that variability and change over time. And she was going to do it for two things that she considered that are considered very important for older adults, and that's their health and social goals. Okay, so older adults obviously want to maintain their health, but they also want to maintain their social goals, their relationships, for example. So she focused on health and social goals, and in this initial survey, she wanted them to come to the system, be able to enter what their goals were, as well as enter a bunch of other information about their social context, about their information that would help her learn things about their personality. And so they have all kinds of instruments for measuring these things in her field. And so this initial survey was to help get that baseline information and to populate the system with their health goals, their social goals, and their social contacts. So social contacts would be, I want to regularly maintain contact with my mom and my sister and my best friend Joe or something like that. Okay. And that part of the survey actually took somewhere around, we anticipated it would take around an hour. Some people did it faster, but in general it was around that amount of time. And then they would be given a daily survey. So on a daily basis, you would ask them other questions to learn about their positive and negative mood, for example, on that day, or learn about their stress on that day. And she would do this on a daily basis. 75% of the people in the study would do 100 daily surveys, so they would do this every day for 100 days. It's pretty painful, but they did it. And this part literally took maybe 5 minutes a day. Okay, it didn't take a long time, but it certainly is an investment in their time. 25% of the people would do 4 of these 7-day bursts. Okay. Yeah, and it's a little hard to believe sometimes that you could get people to do this, but she was able to recruit a good number of people. I believe we had, I think it was around a total of 100 people participate in this survey. Okay. And then there would be a post-survey where they would get some feedback about the project and so on. So we designed a system, and just a web-based system my student worked on. It's driven by a database. They would get an invitation email. They would click on a link in that email. They'd go to the web page where they'd get a welcome. They'd be able to create an account and sign in. They would then go through the IRB consent process. We had to have a way of getting IRB consent, but without being there with them to sign it, so we had a way of doing it online that was acceptable to the IRB folks. I'm sure a lot of you have dealt with IRB and you know how that works. It can be painful sometimes. And then they would fill out that initial survey, potentially long, up to an hour. And they would then go to a next steps page, which would describe to them what was going to happen next. Things like you will start getting an email every day reminding you to fill out your daily survey, and so on and so forth. But actually up there in between here, they would get assigned to one of the two groups. Now they wouldn't, they would know this. They didn't know that we were splitting people up into these two groups, I don't believe. But they would get assigned to either the burst group or the 100-day group, okay, the continuous group as we call them. Okay, and so then at this point they would, their data would be entered. We had a verification process that we would go through where the research team, specifically Shannon and Tuan, would go look at the goals that they entered and make sure that they made sense, because we're going to use those to populate our daily questions. So, if their goal was, exercise more often, that would be a good way to phrase it. If they wrote a goal like, my goal is to, I don't know. I don't even have a good example. There were some bad examples in there, and I don't have them on me right now. But they could enter stuff poorly, and it wouldn't make sense when it was populated into the automatic sentence that I'll show you in a minute. So we would just have to verify their input to make sure it made sense. And if it didn't, or if it wasn't a health goal, so if they, for a health goal, entered something like a social goal or something totally unrelated like an educational goal, we'd have to go back to them and say, we were really looking for a health goal here, so give them an example and see if they could come up with something that would work. So that's the verification stage. And after that, they would then go into this daily pulse email stage. This got a little messed up in the transfer over, but they'd get a daily email. We would actually send that email, if I remember correctly, twice, once in the morning and once in the afternoon, reminding them to fill out their daily pulse for that day. They would hopefully fill out their daily pulse right here, and after they fill out their daily pulse every day, they could then look at a visual representation of their input up to that point in time. Okay, and then they would repeat this. They would repeat this for 100 days if they were in the 100-day group, or they would do it for 7 days if they were in the burst measurement group, and then they would take a few weeks off and then do it again. Okay. So let's move along here. So this is just an example of what the daily survey looked like, and I just realized because we put this on the PC, I can't do this interactively, but I was going to click on this and show you. These are just slider buttons. They'd go here, and every day they'd answer this question. So rate your progress towards your goal of maintaining healthy weight. So when they entered their health goal, what they said was maintaining healthy weight, and we take that and we populate the question that they would then answer on a daily basis. And there's a bunch more of these. They go all the way down. There's some stuff about mood and stress and so on. So they go through and they just grab these sliders and they move them along. One of the things we realized after this study is there's probably some interesting questions to ask when you're doing a digital survey like this as to how you should initialize all these bars. We initialized all the sliders to middle, but that may not be the right answer. And I don't know, there might be literature out there that says how to do this, but we hadn't seen any of it. And if any of you are familiar with literature that might speak to that problem, I'd love to see it. So that's something we actually may look at in the future. You'll see here that this goal, rate your progress towards your goal of my new daughter. Now that is one that didn't make sense. My guess is Tuan, my student who took the screen capture for me, did this with some data that hadn't been verified. So that should have been something like, towards your goal of keep in touch with my new daughter. And it actually should be my daughter-in-law, because that's what it was in this case. It's hard to get a new daughter really quickly like that. So yeah, this particular case, it was a daughter-in-law. I do remember what this was. And so they would do this on a daily basis. Okay, most of them were sliders. Some of them were checkboxes and so on. If I have time, I can show you afterward. If you're interested, I can show you that on the Mac. So they would do this every day after they're done filling it out. It would then take them to a visualization page. And again, this is not what it looked like. I could show you this as well on the Mac. But when the visualization page opened up, it would look like this window up here at the top, except for you would only see the meter up there at the top that goes from red to green, and the legend and the little click to hide detail button there up in the upper right. And so they would see a bunch of these. They'd see one for their health goal progress, below that their social goal progress, below that maybe stress and optimism and so on. They'd have a bunch of these meters showing where they are for this day. So the triangle right here, let's get my pointer, represents their answer for today. So that's what they answered today. This person answered great progress towards their health goal. Their average answer so far in the study was somewhere around here. Okay, so they know where they fall with respect to their average. They know whether they're doing, whether they're where that average falls with respect to great progress to no progress. And if they click to get more information, they would come down here, and this is an interactive visualization. So as I moused over, you'd see a little circle pop onto the value or to the point in time where they're moused over, and they could see the value associated with that, so what they entered on that particular day. Okay, so they could see their time series. They could see, in this case, that variability, for example. And they could also see a histogram of their goal progress. So as they moused over these, they'd see how many times they answered, great, which is what this bar was over here. Oops, didn't actually mean to click. And good, and down all the way to poor. Right? So they'd see how their answers had been distributed. And they could do this for any of those aspects that we were asking questions about. And at the very bottom, they'd see what we call their pulse, which is this image here. It's just a radar chart. It's a radar chart with axes for stress and optimism, their progress towards their goals, their social contact satisfaction, and low negative mood and high positive mood. Right? So ideally, optimally, you would be on the dotted line. That's the optimal pulse, okay, around the outside. The blue line is their pulse for today. So they're actually doing really good today compared to the optimal. And the green line represents their average pulse. Okay, so they could see overall how they've been comparing, how they compare to their average over time, and they can see how they compare to the best possible pulse they could be getting. Okay, so what did we learn from this? Let me catch up here. We, meaning from the computer science side, we were interested in asking a few questions that are a little more specific to the visualization. One is, what is the association between today's goal progress and using the personal feedback portal? So we call that visualization page the feedback portal. The second question is below average goal progress on the previous day related to the current goal progress? And we call that the lag effect. And is that lag effect of poor goal progress yesterday attenuated when participants interact with the personal feedback portal? So we want to know, does it have an effect? Is there any relationship, first of all, between how they're performing and whether they look at the visualization? And is there any effect on looking at the visualization on today's progress with respect to yesterday's progress. Maybe a little confusing. So let's look at these individually. So what is the association between today's goal progress and using the personal feedback portal? So Tuan and Shannon ran the statistics on this. I have a paper that you could read the details on if you want to know the statistical analysis they used. But what they found was that on days when you do poorly, you were more likely to use the visualizations. So when people did not do very well, they were more likely to use the visualization than on days when they did do well. Okay? So that's interesting. If they did bad, potentially what they're doing is they're looking at the visualization and reflecting on what they've done, maybe why they're doing bad, or comparing it to what they've done in the past. Okay. The second question is below average goal progress on the previous day related to current goal progress. The answer to that one was yes. If you did poorly yesterday, you more than likely did poorly today as well. Now this is important to know because people don't just go from doing really bad generally to doing really good in something like a health goal progress. So the way Shannon likes to put this is it's hard to get out of a rut. So if you did bad yesterday, you're probably going to do bad today. That's typically how it worked with the data that we collected. But the interesting thing is, on that third question, that lag effect there, is it affected at all by looking at the visualization? And the answer here was that it was. So today's goal progress is linked to yesterday's. We know that from the previous question. And those who did poorly yesterday are likely to also do poorly today, as we said. However, that effect is weakened when they spent time on the visualization. Okay, so I should have said before that we monitored the time that they spent on the visualization. So what did they click on? How long did they look at it, and so on? Okay, so we knew that they were using the visualization tool to some extent. And so this was really interesting. So it says that what they do, if they do poorly, they're going to potentially look at the visualization, maybe reflect on why they're doing poorly. We know they'll probably do poorly the next day, but if they look at the visualization, they're not going to do as poorly as they would have if they hadn't looked at the visualization. Okay, so that was really kind of exciting to us because it gives us some indication that the visualizations are having an effect, potentially engaging people, helping them reflect a bit on their answers, okay, and using that information to hopefully try and improve. This is just a graph showing that the red line here that you see, this is the line, so we've got above or below average yesterday along the horizontal, and along the vertical axis we have today's health goal progress. And really all I want to point out here is the red line is for what we call the lower 25% duration, so those are the people who spent the least amount of time looking at the visualization, and the upper 75% duration, the people who spent more time looking at the visualization. And so those who spent very little time are this red line here with the steeper curve, and those who spent more time are on this flatter curve, and this flatter curve represents that attenuation of that effect. Okay, it's not as bad as it would have been if they hadn't looked at the visualization. So that was those were encouraging results, and it's interesting to me and to my team because we're very interested in taking data that's being collected about people. In this case, it was data about their goals and their moods and social context and so on, but it could be monitored data, it could be any kind of data, and feeding that data back in a way that's useful for them to reflect on it and hopefully make some kind of change if necessary. Yep.
Did you get any data about self-motivation? Because I'm just wondering if people who spent more time looking at it could also be more motivated for health changes.
That's a good question. Did we have any questions in there about self-motivation? I don't believe we did, but we could say that in general our group is potentially a little biased because they're part of a pool of people who have agreed to participate in studies like this on campus. So they're part of what we call the Life Registry. I don't know how many people are in the Life Registry, but they're people who are motivated to, they're motivated enough to be able to want to participate in research that might benefit them, some way in the future. So I don't know if that exactly answers your question, but I don't think we had, if I remember correctly, any specific questions about motivation. Any other questions? Okay, so In terms of the temporal frame question that Karen had, we found that the burst group statistical distributions were positively correlated with the continuous group, so that's good. That essentially says that you don't have to have people do it every day for 100 days. You can have them do it for 7-day bursts, take some time off, do it another 7 days, and so on. And that this picture really isn't showing much. It's just showing what the distributions look like with the bursts as opposed to the 100-day measurements. And so this is a really exciting thing for in their field because they can do these more fine-grained measurements but not have to do it in the continuous fashion, which can be certainly pretty annoying to people. And some of the people expressed their annoyance in the end after they did we had a post survey at the end, and but they had agreed to it, so they knew what they were getting into. But some of them did say it was difficult, and we had people go on vacation, for example. If they were gone for too long, we had to actually kick their data out. But if they only missed a few days, we kept it in there. Let's see, where are we at? Okay, so I'm going to talk about one last project, and this is another project that I'm working on. And in some ways, it's not related to aging and any of the stuff we've done, but I look at it as being related to aging, and I will explain why. In this particular project, we're interested in looking at energy consumption feedback. Okay, so it's really focusing on energy. And the question is, how do we effectively use monitored data as visual feedback to inform behavior change in home inhabitants? So I kind of took energy out of that question there because I think this could apply to energy. It could also apply to ADLs. It could apply to anything where you're monitoring people, and you could potentially use that data effectively to inform change in them. And in them in particular, not necessarily through a caregiver or somebody who's looking at their energy consumption data, but by feeding it back directly to them. A lot of people have looked at giving information to caregivers and giving information to family members and so on. Not so many have looked at how do you give it back to the person themselves. Question?
You might want to talk to a few of the people in this room because Pullman is a test bed for the smart grid, and so we're getting feedback.
Right, I saw some of that stuff earlier today. It's exciting that you've got some of that data, and yeah, I think there's really lots of interesting things going on. So let's see. This is the question we wanted to answer. More specifically, how can interactive systems help people adopt more sustainable electricity consumption behaviors? And we could easily replace that again with how can interactive systems help older adults adopt more independent or maintainable health behaviors. So I look at this awareness question as a more general thing. Okay? But we are working in the electricity domain for this specific project. And when we started this, we looked at a lot of the tools that were out there. They kind of fall on, at least these two axes were the ones a couple of the axes we were interested in looking at. We were interested in looking at how often does it give feedback. So you've got very intermittent feedback over here, and you've got always on feedback on the far left there. Intermittent feedback might be, for example, like you get your monthly bill, right? And it shows you how many kilowatt hours you've consumed this month. And sometimes it'll give you that comparison to that same month the previous year, which is actually really cool. They found actually that particular finding, there was a study done that showed that helped people a lot in making some significant changes. Whereas in the always on, those typically fall under these kinds of devices where you've got these monitors that go in the outlets, and then you plug an appliance into it, and then it just continuously tells you how much energy is being eaten up by that appliance. Then you've got other things like these one-time, very appliance-specific. So the vertical axis here is appliance-specific to whole home-specific. Things like your energy guide, or what we would call a very intermittent and appliance-specific description of consumption. Whereas all the way up there in the upper left, you've got your meter, which tells you your entire home's consumption. Okay, and it does it all the time. So this is kind of the space we were interested in looking at in terms of feedback. And then there's also kind of PC software tools where you can, depending on what kind of data is being monitored, you can get that information back, maybe on the whole home basis, maybe on individual appliance basis, depending on what kind of monitors you have in the system. But it's more of a pull action. You have to go to the PC and you have to run that software, or you have to go to some website and pull your data from it, as opposed to something like, this always-on device here, which glows a certain color if you have high consumption and glows a different color if you have low consumption. And it's just something you could see at a glance. You don't have to go and actively focus on and pull that data. So this is the space that we're interested in playing in and studying. And previous literature had told us that there are certainly some things you can do for making feedback effective. It should be frequently updated, so being more towards that always on is probably good. But if it's always on and not updating, that's bad. So it needs to be updating frequently. Should be interactive. A lot of the studies that had been done in the what field? The sustainability field had not looked at interactive applications. They had looked at just kind of static presentations of data. They should be appliance specific, and they should be able to allow you to do comparisons to your norm or historical comparisons over time. And they need to be longitudinal. So in order to maintain behaviors, you need to keep getting this data over a long period of time. So we knew a bit about, from previous literature, what worked in terms of effective feedback, but most of these were not looking at interactive feedback devices. Okay. So we, based on what we had read in the literature, we developed what we call the three-step approach. It's not a theoretical approach by any means, but the 3 steps that we decided were necessary to help people change their behavior with respect to energy consumption is that first they have to be aware of their consumption patterns. They have to be aware of what it is in their home that's consuming energy and generally how much energy it's consuming. Then they have to be able to, the system has to be able to inform changes. So what we mean by that is we need to provide ways for them to kind of set goals and see how well they're performing with respect to those goals. And finally, the last step is we need to help them maintain sustainable behavior. So if you do something that works out well for a few months and then it peters off and nothing happens, then that's useless. So it needs to be maintainable over time. And so we wanted to then study and figure out how to design a feedback system to work within this context of this 3-step approach. So we were also interested in location-based feedback. So a lot of the feedback to that point had been temporal. So time series, kilowatt hours consumed, for example, for a particular device over time. We were interested in taking a look at location-based feedback, meaning having people look at feedback, for example, on a map or a floor plan of their home. Mostly because we think it might potentially be interesting to leverage their knowledge of their home and the routines in their home and what happens in their home. Because first of all, everybody's home is different. But we have very detailed knowledge of the kinds of things that go on in our home. We know where the Wii is, for example, right? And so it might mean something to me if I look at this particular room and I see a glow in this corner. That means one of my kids left the Wii on, or they're playing the Wii right now and they're supposed to be in bed. So we have this intimate knowledge of our home, and maybe we could take advantage of that in providing feedback to the inhabitants. And in addition, maybe we could take advantage of just how they move about their home to figure out where to put feedback devices. That's another thing that we were interested in looking at. So there's so many degrees of freedom in figuring out how to provide this information back to people. So we settled on studying always-on devices. And we wanted it to be based on some kind of map. These are just some mock-ups, of a drawing of a visualization of some sort on a wall there. This is one on a floor mat. As you walk out the door, you might see this, and it might trigger you to make some changes before you actually leave the house. Like you might realize, the light is on upstairs in this room. I should go turn it off. If it was visualized on that, let's say a floor plan down there. So we set out to do a field study. In this field study, we wanted to know what do people know about how electricity is consumed, and how do we integrate, if we were to build an always-on device, how would we properly integrate it into the home? Okay, so this is just a field study, just to go out, talk to people, do a semi-structured interview. We did 4 households. There were 3 couples and 2 housemates, total of 4 students and 4 professionals. We did these contextual interviews. We did it in their home, so we went to their home had pizza, sat down with them, had them go through a number of tasks, had them answer questions about electricity consumption, their practices. We tried to understand their current awareness. We had them do a ranking task where they wrote down what are all the devices in your home that use electricity, and so they'd go and write all these down. And then we'd say order them from the most to the least, and they'd do that. And in this particular one, we had them do it separately. So if it was a couple, we had them do it separately. And then we had them come back and put it together, and we'll talk about that in a second. And so we did some tasks like that, but most of it was a semi-structured interview of questions. And we had them do some participatory design as well. So we had them draw a floor plan to show us how they might represent their appliances on that floor plan, for example. And what did we find? So one of the things we found was that they rarely agreed on what was consuming energy and what consumed the most energy. So one of the things that comes out that was important to us in this is that you have multiple people in a household, they're generally not going to agree on, not going to be on the same playing field as far as what they know about their electricity consumption. Okay, so that's one of the things we have to take care of immediately. If you're going to use a feedback device, you're going to have to reconcile some of these differences and get everybody on the same playing field. They would say things like, I don't really know what appliances really use. I'd like to think that I do, but I probably don't. This actually could have come from me myself, because I could say the same thing. I think I know what consumes energy in my home, but I was actually surprised today when I was in your lab and you turned on one of those sets of lights and it nearly doubled the consumption in that room. That was ridiculous to me, and I would never have guessed that. Okay, so there's people in general don't know what devices consume how much energy in their house, at least from our small study. People are interested in comparing to themselves. They don't necessarily want to be compared to others. There's a lot of literature out there saying you should make this like a game, and they should be compared to the other people in the neighborhood. And I think there's certainly some ways to do that effectively. People are very concerned with the fact that there are lots of variables that go into consumption, and that it's not fair to compare them to the other people in their neighborhood, because those folks might have a much bigger or a much smaller home. They might have a lot more people in their home, and so on. So kind of how do you level the playing field there? So there were certainly some concerns there. There were certainly a lot of challenges for adoption. The first challenge is that people have different mental models. They also have different stages in that kind of three-step process where they fall. So one person may be very aware of their consumption, whereas another may not be aware, and so one may have moved on to the second stage and the other might be in the first stage. So they're different stages that they're at, and they may have different mental models about, for example, their living space here. One of the other challenges is just how do you properly integrate into the home? There's aesthetic concerns, there's privacy concerns, and so on. And so here's a quote from one of the persons. I would frame it, laminate it, and it would be color-coded. And then you had other people say things like, there's no way I'd put this up in my house. So I'm almost finished here. I know I'm probably over time. But the last thing I wanted to say is we did a 2-year, so we did this initial study. We then got funding to do a more full-blown study, a 2-year NSF project. We're currently in the field study stage for that one. We then have a large participatory design stage we're going to go into, and then we're going to take what we learned from that design stage, build some actual prototype feedback devices, and do a long-term deployment in 1 to 3 homes. Okay, and when I say long-term, I mean 3 to 6 months or so of feedback of real-time consumption data to the inhabitants of the home. And of course, there are lots of things that we need to look at, all the things that I've mentioned already. There's lots of variables that come into play. And so it's kind of a complicated field to work in. But one of the things that we've been thinking about lately is this analogy in terms of how people manage their time. If we think about how people manage their time, there's not kind of one device that does that, right? So, for example, I have an awareness of what time it is during the day because the sun is up or the sun is down, right? It's dark or it's light. I have this general awareness of that immediately. I know what time it is now because there's a clock in the back of the room, right? And I can look at that and I can get that time. And that's a little more detailed than the sun, unless I have a sundial or something. We all have a mobile device, or most of us have a mobile device with us, right? We walk around with our watches, so we can tell time by looking at our hand. We always have it with us. And if we want to get a look further out, we can use a calendar. We could look at time on different granularity. We can then put our schedules onto a calendar, right? A lot of us do this with, Google's calendar application and so on. And so we manage our time in lots of different ways. There's not just like one device that works, right? There's different versions of similar types of devices. And then there's similar issues. Does everybody want that clock in their house in the back of the room? Maybe not. Some people want that clock, or some people want that clock, but they're all serving the same purpose, right? And some of these clocks actually have of audio associated with them. Not all clocks do. So there's lots of different ways that we manage time, and we can furthermore set goals in terms of time, right? We have alarms that we can set that go off and alert us. And so we're thinking about looking at the energy consumption awareness in an ecosystem like this, where there might be lots of levels of devices that need to exist in order to properly help people maintain an awareness of their consumption patterns. So that's about it in summary. I think awareness is necessary for self-regulation. We saw that in the Pulse project. It's also going to be necessary for things like energy consumption, and we can use technology to help promote that awareness and inform behavior change. But I think we need to understand how to build these systems, not just kind of one tool that's going to do it for us. Okay, and like I said, we're interested in feedback, whether it be energy, ADLs, social and health goals, etc. So that's it. Thanks for coming. Sorry I ran a little over time. And these are the NSF funding sources for our IGERT and my awareness project, and a bunch of people who've been working on these projects with me. So thank you.